Good afternoon, everyone. My name is Wendosen. Today we're going to discuss about limiting and excess reactants. The reason why I picked this topic is so many students have difficulties in identifying limiting and excess reactants. What I would like to do is I'm going to give you some example related how to determine the limiting and the excess reactant. Let's pick an example. Let's say that I have zinc react with silver nitrate. This will give us zinc nitrate. I put here AQ. AQ stands for aqueous solution, which is a solution dissolves in water, plus silver will be formed. By the way, this type of reaction is called a single replacement reaction. So one thing that we have to realize before we go further, we need to balance the equation. So this equation basically is not balanced because we have two nitrates on the product side, we have one nitrate, so on the reactant side. So we basically have to put a coefficient 2 to balance the nitrate ion. As one of the easiest way to balance equations, if you have a polyatomic ion, please start with the polyatomic ion first. We have nitrate ion here, and then we give a priority to the nitrate ion because we have two nitrate ions, so we put 2 as a coefficient here. By doing 2, we will have 2 silver and 2 nitrate. So when we come here, we have to put another 2 so that the equation is balanced. We don't need to balance the zinc because we have 1 mole of zinc react with 1 mole of zinc nitrate. Okay, so like I say, our goal is to determine the limiting and excess reactant. Why we need to know limiting and excess reactants? The reason we need to know limiting or excess reactant, it will help us to identify the amount of products that we will obtain once zinc reacted with silver nitrate. By the way, we're going to write the status. It's very important to write the physical status of the reactants and products. This is going to be S, refers to as solid. Zinc is a metal, we write S as well. This we have to write AQ, which is aqueous solution. So let me give you an example. Suppose we have 3 grams of zinc. Let's say, let me write here, when 3 grams of zinc metals would place in 4.5 grams of silver nitrate solution. Silver nitrate solution, this is an example. As you see that zinc nitrate and silver will be formed. So the question here would be that what would be the limiting reactant? How much would be your limiting reactant? That's one question. What is the limiting reactant? Okay, I'll put as question 1. And question number 2 would be how many grams of silver would be formed? So that would be the next question. So like I said, the very first important thing in order to solve this problem, you would need to know which one would be your limiting reactant. Is that zinc or silver nitrate? So we have 2 amounts here, 3 grams of zinc and 4.5 grams of silver nitrate, and we are not sure whether zinc or silver nitrate is going to be your limiting reactant. So one way to determine is we're going to go back to the balanced equation. According to the balanced equation we have here, 1 mole of zinc react with 2 moles of silver nitrate. So 1 mole of zinc in terms of molar mass would be about 65 grams of zinc. You would get this value from the periodic table. So 65 grams of zinc would react with 2 moles of silver nitrate. So when we wanted to change 2 moles of silver nitrate into molar mass, we have to find the individual weight of silver, nitrogen, and oxygen. And silver has 108 gram, nitrogen has 14 grams, and oxygen has 16 grams. So I don't have any space here. I'm going to remove this, and then we're going to move to the next slide. So bear with me, please. So we basically, I'm going to write down the equation for you. The equation was zinc zinc react with 2 moles of silver nitrate provided as zinc nitrate plus silver. So we wanted to find out the molar mass of silver nitrate. So what we do is 1 mole of silver nitrate would be equals to 107 grams of silver plus 14 grams of nitrogen plus 48 grams of oxygen. Remember that we have 3 atoms of oxygen. We multiply 3 by 16 here. That's how we get 48 grams. So when we add them up, I'm going to use my calculator here to add them up. Just give me a second. That's going to be 107 plus 14 plus 48. So that will give us about 169. I think the weight of silver is not 107. The weight of silver is 108. That's my fault. So I'm going to change here 108 gram. So 108 plus 14 plus 48. That would give us altogether about 170 grams of silver nitrate. However, we have 2 moles. Okay, so if 1 mole of silver nitrate equals 170 grams, 2 moles would be 2 times 170 grams. That will give us 340 grams. So, which means that 65 grams of zinc would be react with 340 grams of silver nitrate. And what was given to us was initially 3 grams of zinc requires how many grams of silver nitrate. That's very important to identify. That way we can able to determine which one is our limiting reactant and excess reactant. So basically what we do is some people like a crisscross system. You multiply this by this and this by this. We can say that 3 grams of zinc times 340 grams of silver nitrate divided by 65 grams of zinc. So 3 grams of zinc times 340 divided by 650 grams of zinc. This is a conversion factor. Remember that the desired unit has to be on the top. This is a desired unit. This is what you are looking for. This is the unwanted unit. So zinc and zinc will be crossed out here. And 3 times 340 divided by 65. Let's see how much that would give us. 3 times 340 divided by 65, it will give you about 15.6 grams. 15.6 grams of zinc. I'm sorry, 15.6 grams of silver nitrate. So this is very important number. Now we're going to compare the amount that was given to us. The amount that was given to us was 4.5 grams of silver nitrate. But when we did the reaction, when we do the calculation part, for 3 grams of zinc, you need 15.6 grams. So 3 grams of zinc needs 15.6 grams of silver nitrate. Now, we need to compare these values. We have two values here, 15.6 grams of silver nitrate, and what was given to us was 4.5 grams of silver nitrate. So according to this, the reality is for 3 grams of zinc, you should get 15.6. However, what we had at hand is 4.5 grams of silver nitrate, which is a very small amount. So in that case, this is going to be our limiting reactant. This is our limiting reactant. Okay, so we identified our limiting reactants that would help us how much silver that we get or how much zinc nitrate we get at the end. So I'm going to move to the next slide and we can solve this problem. The question, remember the questions that we had was how many grams of silver will be formed from 3 grams of zinc and 4.5 grams of silver nitrate. Okay, let me move to the next slide. Okay, so now we already determined that silver nitrate is going to be our limiting reactant. So I'm going to write the reaction here for you. The reaction was zinc plus silver nitrate gives us zinc nitrate plus silver. And remember, we always have to balance the equation. So the question is how much silver will be formed? How much silver will be formed? So we're going to compare 2 moles of silver nitrate with 2 moles of silver. But remember, this is not a mole equation. This is a mass to mass problem. Mass of the reactant, mass of the silver nitrate has to be compared with mass of silver. So we already calculated the mass of silver nitrate. The mass of silver nitrate initially was 340 grams, right? 340 grams of silver nitrate would give us or would provide us 2 moles of silver, and 2 moles of silver in terms of gram would be 2 times 108. 2 times 108. What is 2 times 108? It might be 216 grams. 216 grams of silver. Good. Now, if 340 grams of silver nitrate would provide us 216 grams of silver, then we would ask 4.5 grams of silver nitrate would give us how many grams of silver? Again, we use the crisscross problem. So we would say 4.5 grams of silver nitrate times 216 grams of silver over 340 grams of silver nitrate. So this is a conversion factor. The unwanted unit would be crossed out, so we'll cross out this. So we multiply 4.5 by 216. 4.5 by 216, what do we get? We will get 972 grams, and we divide that by 340. If we divide this by 340, we get 2.85 grams of what? Silver. So the answer, the final answer is 2.85 grams of silver would be formed from 4.5 grams of silver nitrate. So the objective here is that this is the final answer, but the objective here is that to determine which one is your limiting reactant. Okay, once you know your limiting reactant, you can come with the answer. How much silver here, can be formed, or how much zinc nitrate will be formed. Maybe as a homework, I would like to give you, if you have 4.5 grams of silver nitrate, let's say you have 4.5 grams of silver nitrate, how many grams of zinc nitrate you'd get? I did silver for you, you can do zinc nitrate. So I will add some other examples on my next slide. Please stay tuned.